We're counting down the 10 most extreme German war machines ever built, ranked from explosive remote weapons to the largest tank concepts in history. These vehicles were engineered to deliver maximum destruction, combining unprecedented firepower, armor, and even remote control, yet often at a terrible strategic cost. Which design pushed the limits the furthest? Let's begin with number 10. Number 10 on the list is small but no less extreme, the Goliath remote demolition vehicle. The Goliath, a tracked machine barely the size of a wheelbarrow, carried up to 100 kilograms of explosives and was guided by a long spool of cable from behind the lines. Over 7,000 were built, yet their thin armor and exposed control wires made them easy targets for Allied rifles and shrapnel. The larger Borgward 4 was radio-controlled and able to deliver a 500-kilogram charge, offering more punch but remaining vulnerable to artillery and anti-tank fire. Both saw action in Italy and Normandy, where muddy fields and quick-thinking opponents left most immobilized or destroyed before reaching their targets. These remote weapons promised surgical demolition, but in practice their reliability and tactical impact fell far short of their explosive potential. Only 2 Sturer Emil tank destroyers ever left the factory floor. They were prototypes nicknamed Max and Moritz. Built on a stretched Panzer III chassis, each mounted a 12.8-centimeter Canone 40, a gun capable of punching through 130 millimeters of armor at 2 kilometers. Deployed with the 521st Heavy Tank Destroyer Battalion on the Eastern Front in 1942, these machines were slow, under-armored, and open-topped, but their firepower was unmatched at long range. One was lost in combat. The other was captured by Soviet forces and shipped to Kubinka, where it still stands today. Its barrel is ringed with over 20 kill marks, a silent record of the tanks and bunkers destroyed before the Sturer Emil concept gave way to even heavier tank hunters. Jagdtiger rolled onto the battlefield as the heaviest tank destroyer ever put into service. Weighing over 70 tons and protected by up to 250 millimeters of frontal armor, it carried a 12.8-centimeter PaK-44 gun that could destroy any Allied tank at more than 2 kilometers. On the Western Front, especially during the Ardennes campaign, its presence was intimidating until it had to move. The same Maybach engine used in lighter tanks struggled under Jagdtiger's mass. Out of roughly 80 vehicles built, many were left abandoned or blown up by their own crews after mechanical breakdowns or running out of fuel. In the end, more Jagdtigers were lost to failed drives and stranded marches than to enemy fire. It is a stark lesson in the limits of brute force when mobility and logistics break down. Ferdinand, later known as Elephant, was a heavy tank destroyer built for one purpose: to annihilate enemy armor at long range. Weighing nearly 70 tons and protected by up to 200 millimeters of frontal armor, it was almost impervious to Soviet guns from the front. Its 8.8-centimeter PaK-43-2 gun could knock out tanks before they could reply. But at Kursk, where 90 of these vehicles saw their first major action, design flaws became fatal. Without a bow machine gun, Ferdinands were easy prey for infantry once immobilized or flanked, and mechanical failures stranded many in the field. After heavy losses, surviving vehicles were retrofitted with a bow machine gun and other improvements, becoming Elephants. Yet even with upgrades, their sheer weight and unreliable drivetrain meant many were lost to breakdowns, not enemy fire. Ferdinand's story is one of overwhelming firepower, undone by blind spots in its design and the realities of frontline combat. Sturmtiger took the Tiger-Wise heavy chassis and transformed it into a weapon built for urban devastation. Its main armament was a 38-centimeter rocket-propelled mortar. It fired shells weighing about 345 kilograms, each round larger than a standard oil drum and packed with enough high explosive to level a building. Only 18 Sturmtigers were produced, and their most infamous appearance came during the Warsaw Uprising in August 1944. On August 13, 1944, A single shot from a Sturmtiger struck the Prudential building, peeling away most of the facade and sending shockwaves through the city. Survivors described the blast as deafening, with debris raining down for blocks. The vehicle's thick armor and 5-man crew offered protection as it crept through city streets, but its impact came at a price. Each Sturmtiger could carry just 14 massive rounds, and reloading required a crane and a careful dance with volatile ammunition. In close quarters, the Sturmtiger's firepower was unmatched, yet its slow traverse, limited range, and cumbersome logistics kept it from reshaping the battlefield beyond isolated acts of destruction. Karl Gerhardt thundered onto the battlefield as a tracked siege mortar, dwarfing even the heaviest tanks of its era. Designed by Rheinmetall, this 124-ton machine carried a 60-centimeter barrel capable of firing shells that weighed over 2 tons, each round nearly the mass of a small car. Only 7 were built, each demanding a dedicated team and a convoy of support vehicles just to keep them supplied. Ammunition arrived on armored carriers converted from Panzer IV chassis, and the process of loading a single shell required cranes, hydraulic lifts, and careful choreography from the crew. Karl Gerhardt moved at a crawl, barely topping 10 kilometers per hour, and every kilometer of travel risked breakdowns or track damage. Maintenance was constant, and firing the mortar unleashed shockwaves that battered the vehicle as much as the enemy. This was siege warfare made mobile, at least in theory. In practice, the logistical strain of fielding Karl Gerhardt meant it could only be deployed for the most critical assaults, and its ponderous speed left it vulnerable if the front shifted. Yet when it spoke, fortifications crumbled, and its presence signaled that no wall was safe from destruction, no matter how thick or deep. Nothing in the arsenal of World War II matched the sheer scale of the Schwerer Gustav and its sister gun Dora. Built by Krupp, these railway guns measured 800 millimeters in caliber, making them the largest artillery pieces ever fired in combat. Each high-explosive shell weighed nearly 5 tons, while armor-piercing rounds tipped the scale at 7 tons. Moving Gustav to the front demanded weeks of preparation. Engineers laid double or even quadruple railway tracks, carved out embankments, and assembled the gun on site. The full emplacement weighed 1,400 tons and required up to 3,000 personnel for operation, security, and logistics. At Sevastopol in 1942, Gustav fired fewer than 60 rounds, targeting Soviet bunkers and underground magazines. Each shot shook the earth, but the gun's fixed position and slow rate of fire meant it could only engage a handful of pre-surveyed targets before its usefulness faded. For all its unmatched power, Gustav's battlefield role was narrow, a monument to excess, as vulnerable to shifting front lines as to Allied air power. The era of the stationary megagun was ending, even as German engineers turned to super-heavy tanks for the next leap in destructive ambition. The E-100 was meant to be the crowning achievement of Germany's late-war tank rationalization effort, the so-called E-series. Designed by Henschel, this super-heavy project aimed to standardize components and, in theory, simplify production across multiple tank classes. On paper, the E-100 would match the firepower and armor of the Maus, but with a more conventional mechanical drive and a projected weight in the 130 to 140-ton range, still heavier than anything fielded by the Allies. Plans called for a 128 or even 150mm main gun, and some blueprints proposed reusing the massive Maus turret. Only a single hull was ever assembled. It was found incomplete by British forces near Paderborn in 1945. Technical teams photographed the chassis, studied the suspension, and shipped it back to the UK for further analysis, before it was quietly scrapped. The E-100 never received its turret or engine, and no complete vehicle was ever finished. Its existence stands as a stark reminder of the gap between Germany's industrial ambitions and the harsh reality of war, where even the dream of rationalized mass production collapsed under the weight of material shortages and battlefield defeat. Maus was the heaviest fully enclosed fighting vehicle ever constructed, tipping the scales at 188 metric tons. Conceived by Ferdinand Porsche and armed with a 128mm main gun and a coaxial 75mm, Maus was designed to withstand any Allied anti-tank fire. Its frontal armor exceeded 200mm, while the turret front reached up to 220mm, thicker than any tank fielded in World War II. Yet for all its brute strength, Maus was crippled by its own mass. The hybrid electric drive, powered by a 1,200 horsepower engine, struggled to move the vehicle beyond 13 kilometers per hour off-road, and even less in muddy or soft ground. Bridge load calculations from the Kummersdorf trial logs revealed that no standard bridge could support Maus. It had to ford rivers in pairs, using one tank to help the other. Only 2 prototypes were built and tested. They were never deployed in combat. The resources consumed by Maus, including steel, labor, and fuel, could have produced dozens of standard tanks. In the end, Maus was a rolling bunker, too heavy for real battlefields, a monument to engineering ambition and logistical impossibility. Its failure set the upper limit for what could actually be built, paving the way for even more fantastical concepts like the Landkreuzer's Ratte. Ratte was the final word in extreme German armored design, a land battleship so vast it bordered on science fiction. Conceived by Krupp engineers in early 1942, the Landkreuzer P-1000 Ratte was projected to weigh 1,000 metric tons, with a footprint longer and wider than a modern naval destroyer. Its planned main armament was a pair of 280mm naval guns, the same caliber used on Scharnhorst-class battleships, housed in a massive turret. Secondary weapons included multiple 128mm anti-tank guns, anti-aircraft cannons, and even early sketches showing torpedo tubes, as if the designers could not decide whether this monster belonged on land or sea. Armor was drawn up to reach 250mm on the front, thicker than any tank ever built. The propulsion system called for multiple submarine or ship diesel engines, but even the most optimistic German estimates put its speed at 40 kilometers per hour, a figure modern historians dismiss as fantasy. The Ratte could not cross any bridge or use existing railways. Its weight would have crushed roads and infrastructure. Moving it would have required purpose-built tracks, and it would have been an ideal target for Allied bombers. Albert Speer, Germany's armaments minister, reviewed Krupp's proposals and, along with the Army Ordnance Office, rejected the project as an impossible drain on steel, fuel, and manpower. By mid-war, with resources dwindling and the Eastern Front collapsing, even Hitler lost interest. No prototype was ever built. The Ratte survives only in sketches and correspondence, a fantasy of naval firepower on tracks, unmatched in scale, but doomed by its own absurdity. If Maus was a rolling bunker, Ratte was a fortress that never left the drawing board, the ultimate symbol of how far German planners strayed from reality in pursuit of destructive spectacle. Across all these extreme machines, one truth stands out. Sheer technological might cannot overcome flawed strategy or ignore limits. In chasing superweapons, Germany sacrificed practicality for spectacle, fueling defeat, not victory. Today, these ruins remind us that obsession with power often leads only to self-destruction. What surprised you most?